MacBook Pro. So 15 inches, and it says it's dead. So this is A1990, and it says it's dead. So let's quickly take our board out. As usual, we take the back cover out first before we connect power to the device. We don't want to create more harm to the machine um, by sending power to the device, not knowing what state the device is in. So first and first, we take the back cover out. That will give us an idea using a multimeter what state the device is in. Okay, so as usual with the A1990s, so typically if it's not liquid damaged, the first thing we do is we disconnect the battery and then we check for a short. And we usually start checking for a short on the PPBUS line. I'm just going to open up the board view so you guys can follow along with me. This is going to be an 820-01. So it's 820-01041. So we will start by checking what we have on our PPBUS. Let's see if we have a short run on our PPBUS. That we can confirm by using either of the fuses here, which are on the PPBUS line. So we already have our multimeter set to continuity mode. Our battery is disconnected, our black probe to ground, and then red probe, let's see. And we don't have a short. Okay, that's fine. Now the next thing we want to do is we want to see if we have a short on the side of the NAND, which we can check that on the right side. Okay, we don't have a short. So these are the two quick shorts we usually test for. So the next thing we want to do now is that we want to connect our charger to see what is it that we have on what we have on our PPDCIN. So charger is connected. Now we are going to measure for voltage. We will be checking to see what we have on our PPBUS line. 12.6 will tell us that we have 20 volt on our PPDCIN, and 12.3 will tell us that we have 5 volt on our PPDCIN. That is 12.3 and fluctuating. Okay, so that basically tells us that we have 5 volt and it's also fluctuating. So that's fine. So the next thing we want to do now is we want to see. So usually when you get 5 volt and fluctuating, there are many possibilities behind that. So that sometimes can be a good thing, which is the fluctuation will tell you that that particular port is trying to boost into 20 volt, or basically makes its way into 20 volt. But because there is an issue at a secondary rail, which in this case is going to be one of the other, because this the A1990s, they work on a system of where they have 4 CD3215 controlling the input voltage. So if one of those CDs fail, what will happen is it will prevent the other three from basically from your machine to get 20 volt. And the machine, it's not going to work if you don't get 20 volt on your PPDCIN. Your machine will work when you're stuck on 5 volt. Your machine is not going to work at 5 volt. It needs to get 20 volt. So if you get a fluctuation of 5 volt and then 0 volt, 5 volt and then 0 volt, that is a good thing. At some that can be seen as a good thing, depending on if. So usually you have that case of one port. So the port, if you, let's say, because we have 4 ports, and then you have one port going 0, 5, 0, and then goes to 5, and then goes down to 0 again, and then it goes to 5 again. Across the 4 ports, if you find three ports doing that, and then one port being steady, That one port being steady, the CD3215 that is corresponding to that one port that is steady, it's what you need to blame. So if you have four ports, and then of the four ports, three will rise and then drop, rise and then drop. So the three that are rising and dropping will be the functional CD3215s, correct, the ones that are corresponding, and then the one that is just stuck at 5 volt will be the one that is what that is faulty. So, but that is behind door number one, and then there are multiple explanations also to in case that's sometimes that's not the case. Sometimes you may have a short, but that is one of the commonest. So that is something you need to look out for. If you have four 63215s and one of them it's stable, the other three are fluctuating. The one that is stable is usually the one that you want to blame. Okay, so let's start again. So we connected our charger to the first board, and we were getting 12.3, and then it drops again. So that is telling us that we have 0.5, we have 0 volt, and then it drops again. So if we check, let's check our voltage here. So we see we have 5 volt, and it should, yeah, so we have 5 volt, and it seemed to be stable. But let's see this, and then we have, okay, 12 volt, and it drops again. Okay, so what we want to do is to be safe, we are not going to connect charger to the other port. So let's go ahead and remove the board, and then we can now find out which of the CD3215 or why the board is behaving the way it's behaving. So we are not going to connect power to the rest of the ports. Let's quickly take the board out and then walk our way through why we have 5 volt instead of 20 volt. It's very important to be very careful around your touch ID when you are taking out when you're disconnecting the cables, because these touch IDs are tied to the board. You don't want to make a mistake by breaking the touch ID cable. That will give you really hard time, uh, which means you have to run individual wires to reattach your cable. And if you fail at doing that, it means you will have a non-functioning touch ID. So just be careful around your touch ID cable so you don't break it. Okay, our board is out. Let's put the shell aside. Let's inspect our board, dust it out a bit. So what you want to do, so we talked about the CD3215s. So these are, you have U3200, one of it, that's another one, that's two, U3100, and then on the other side, on the right side, you will have UB400 and then UB300. Now, so all of these four CDs are going to work as one unit. So basically, they will work on the single channel. So if one of it fails, depending on what region fails in one of the CD3215, if it is a region that basically allow the CD3215s to talk to one another, then obviously three CD3215 will not be. When you have three CD3215 on the board, you will only get 5 volt. You need the fourth one in order for the process to be complete. Now, if the region of one of the CD3215 fails, is of the region that allows the CDs to communicate, then the machine will assume you only have three CD3215 on the board and not up to four. And in that state, your board will only be stuck at 5 volts. So what we want to do is we want to, first of all, measure around our CD3215s to see if we have a short at any of them. That's seems to be fine. Let's check the other one. That seems to be fine. Let's check this one. Okay, we have a short there. We'll go back to that. So we have a short here, and that's gonna be this guy here. So we have a short at UB300. So we have a short at UB. We are measuring the short at UB308, which is a cap there. But I'm pretty sure that that short it's coming from UB300. So just sometimes you may actually have now if that's CD3215. So I'm just gonna so let's just go over it again. Let's connect our charger. So let's start from this side of the port. So 20 volt. Let's switch to. So left and then right probe, we can measure for PPBUS here. Let's see, we get in 12.3 and it drops. Now let's come to the CD3215 itself here. Let's see, we get 5 volt and it's stable. Okay, let's check on the other side. Let's check the other port. 5 volt, that's fine. And then this side. Okay, so we see that we're getting 0 volt at um, we're getting 0 volt at one of the port. Let's check on the other one. And then we're getting 5 volts. So across the 4 ports, we're getting 5 volts across the 4 ports. However, one of the ports we are getting a 0 volt, and then we see that the corresponding so that is going to be the corresponding CD3215, which is in this case is going to be UB300. So and that will be this guy here. So what you want to do is you want to remove um, that CD3215 and then replace it, and hopefully we should have 20 volt afterwards. So again, why? So why didn't he call you? Security refused the guy to come in. Okay. There's actually a small burnt mark on the side. Yeah, it's actually a small burnt mark on the side of the chip. I'm not sure if you guys can see that. See that one there. Can you see that? Yeah. So let's say if you say have a short, and now short is gone. So let's get another CD3215. Okay, we have one here. We're not sure it works. We just hope it does. Okay, that is out. It looks like the pads underneath it moved. Uh, so we're not gonna trust entirely that that was a good installation. Most likely, uh, it was not properly installed because I mean the pads are moving. Uh, so let's see if we have a short grounded. Okay. We don't seem to have a shot around it, but uh, I'm not so hopeful. In any case, let's see. Disconnect charger now. Let's see what we have. We have PP3 with 3.3. Let's check the other side. 3.3 and the other port. 3.3. Let's see. Do we have 12.6 or 12.3? Yeah, 12.3. So we still have 5 volts. We definitely need to reinstall that. Yeah, we definitely need to reinstall it because we're still getting 5 volt instead of 20 volt. 0 volt. Let's flip the charger to the other side. 0 volts, 5 volts, and then the other one, 5 volts. Okay, we need to, let's reinstall that. We were not sure of its installation process. Let's check it out. Yeah, can you guys see that? Yeah, we were pretty much
Yes. Can you ask the courier guy to leave the package nearby you? I'll come and fetch it. Yeah, there's a courier guy there. Yes, it's always. Zina, she contacted me like now. Okay, did you leave today? Okay, I think that's the one. Okay, thanks.
okay. Now we need to also walk around that pad there. we're trying to even out the pads underneath the chip. So we do it from a different board. Okay. That's fine, except we have two pads that are not looking good. Okay, it's time to install it. Be aware of its orientation. Okay. Okay. With a bit of time to cool off. Let's see if we have a short. Okay. You can check from this side. So if we have 12.6 or 12.3, 12.3 we have to, it means we have to go again and reinstall it or replace it, and 12.6 will mean that our installation was good. 12.3, 12.6. Okay, that's beautiful. Now we have 20 volt. So 12.6 tells us that we have 20 volt, and then that means our installation was good, and that also means that the CD3215 that we installed is also good. So if we check here, we should have 20 volt. Now PPDCIN, and that's 20 volt. I'm just gonna see that. So we're measuring at the fuse, and that's 20 volt. Yeah, that's 20 volt. Okay, so 20 volt, 12.6, that it's That's indicative that our CD3215 was successfully installed. Our CD3215 it's working, and also our installation was correct. So it's now put the board in the shell. But before we do that, we know that A1990s are very common with we know that A1990s are very common with the failure of our guy here, uh, C9081. So we will have to do this person a favor by taking care of C9081 before it comes back for a failed C9081. And who knows, maybe at that time also the CD, also that might also kill um, the NAND as a result. So before that happens, we have this client take care of that to avoid loss of data due to a failed cap. So I'm going to explain shortly how that will be the case. Guys, you might wonder how can just a failed cap result into loss of data. I'm going to explain shortly. But the cap looks pretty good. The cap looks good. I think we can just leave it here. So I was talking about C9080 failing. So usually you get a bit of dust around this section, and then moisture contributes to it, and you get a corrosion taking place here. When that happens, C9080 will fail, and C9080 is on the same line to U9080, which is a buck converter that converts the PPBUS voltage into 2.5 volt on two channels to your NAND. So usually what happens is when C9080 fails, it sometimes blows up U9080, and then when U9080 fails, it sends the entire 12.6 volt, which is the PPBUS voltage, to the line of I'll put it on the line of 2.5 volt, which then goes to your NAND chip, and then that will destroy your NAND chip. So usually that is why in the repair we tend to make sure that we remove C9080 completely from the circuitry. However, right now C9080 is looking very good. How? But even at that, it's not safe because after some time, it's bound to happen. So I think it's best to just remove it, because if it's not removed, that is bound to happen, and yeah, it's just remove it just to save this client from, having to experience that. Let's just remove it, and so that will save the client from having to experience the common failure of A1990s. So without the cap there, even if you have corrosion in that section, there is nothing to blow. So there'll be no cap to blow up because So, because when there is corrosion there, the insulation material within the capacitor will basically whatever is on pin one will make its way to pin two, which is whatever is on pin one makes its way to ground, and then you have a shorted cap, which eventually will now kill your U90 80 as a result. So with the cap not there, then this machine will be safe from a failure like that one. So let's test our board. So far we are here because our machine do not start, and we found that that's because we are getting 5 volt on our PPDCIN instead of 20 volt. We measured around and then we found one of the CD3215 was shorted, and then when we looked closer we also found that it had a bunt back. So we replaced that, and now we have 20 volts. So we want to see if we now have a working device. When Gabi comes, we ask him about the installation of that machine. When Gabi comes, you ask him about the installation of that machine. But another thing you can do is, if you have the password, you can log onto the machine using our test drive. But then because it's a 2018, before you're able to log on with the test drive, you have to go change the settings. Remember the security settings? Yeah. Okay. Let's put in 1 or 2 screws. And then let's put in the battery screw as well. We're not going to connect all the cables. We just few cables to allow us to do the testings only. Okay. Let's see what we have. We have trackpad feedback. We have Apple logo. We have a setup sound, and that's a beautiful Apple logo. Okay, that's pretty much it. Thank you guys. We are not interested in the machine put into desktop. So this is going to go through the basic procedures, which is to assemble the machine, do the basic test, and then this can go to the client. Yeah, we obviously just a quick rundown. We had an issue of the device not starting. We did our basic measurements, and we found that our issue was we were getting 5 volt instead of 20 volt, and a USB-C device for MacBook Pro. For Macs, basically they work on 20 volt and not 5 volt. 5 volt would be for an iPad or an iPhone, but for Macs you need 20 volts. So we then had to measure around to find out why we are having 5 volt instead of 20 volt, and then we found that one of the CD3215 was the issue. So we reinstalled the CD3215, and now we have a fully functioning machine. Thank you guys. I will see you guys in the next one.